Welcome to my talk. Thank you so much for coming. Some of you may already know me, but for everyone else, I'm Ashish. Thanks for coming to the talk. I am going to try and have some time towards the end for some questions. So if you guys have any questions, feel free to kind of save it for the end. The talk today is breaking the cloud to rebuild it for Tale of Three Cloud Breaches. Let's just do it this way. This is a disclaimer which I was asked to put in for some reason. A little bit about myself. I've been in the cybersecurity space for a little over 14 years, and currently I'm the CISO of a company called Kaizen, which is an edtech company, and I also run a podcast called Cloud Security Podcast. I know a very obvious name for people who might be thinking, it's like, yeah, I didn't think it's going to last for more than a year, but I've been doing it for 5 years now. Same with AI Cybersecurity Podcast. Personally, as you can, I basically was, I was born in India. I grew up in Melbourne. I'm now getting old in London is how I describe it. That's pretty much, I guess, my current history. But outside of cybersecurity, I enjoy coffee. And if you can't tell, I enjoy men's fashion as well. You can see me later on as well. I want to start with the story of the cloud breach. So fair warning, this was something, this is a video as well. Essentially what had happened, to give some context, we were doing some training as part of the EdTech company, and the way I would describe it is that we got an email with a video link of a YouTube private link, and then, hey, you should check this out. This is something that I found. So I guess for the next 2-3 minutes, if you bear with me, it's basically a reincarnation of what the security researcher had shared with us, and this was a cloud training that we were running. So as I embarrass myself in public in front of all these thousands of people. It should play straight away, I think.
Basically hovering over here. Okay, so he or she is trying to show me that it is the AWS.
Right, so to give you some context, that was a download from the GitHub file. Essentially, we were using a private GitHub repository for our deployments. We had Terraform, ISE, which is very standard for a lot of people. And the intent, at least for the walkthrough we did with everyone else, was that we were using Terraform as a form of showing that, hey, this is what organizations do. This is what you should know as someone who is a cloud security practitioner, that everyone's using Terraform, everyone's going to deploy using Terraform. And this was, the initial part is the file itself that they got access to, because that's what was available to the students. And anyway, the thinking initially was, there was basically, it was in a video, the same way I just paused it, the person also paused it. So clearly, I didn't do a great job at that point in time. If I can find the play button.
Basically hovering over here. Okay, so he or she is trying to show me that it is the AWS. Oh, okay, fair enough. I named it obviously AWS GFS. Okay, so endpoint, I'm assuming that's the account ID. That's the username that I created.
So for context, Terraform, if you are using the non-cloud version, requires you to have an IAM user, which for people who probably are from Azure or Google, it's like having a local user in AWS. Like even if you have single sign-on, you still have to create an actual IAM user for Terraform unless you go down the Terraform cloud path. But it may be, I guess at least when I was doing this, that's what the case was. I haven't touched it since then, so I don't know if it's changed now. But when we were doing this, I think about, I want to say, late last year, just before I submitted the talk, that was the time, that's what was expected. You had to create an IAM user for Terraform, unless you're using Terraform Cloud where the credentials are stored in the Terraform Cloud environment. More on that later as I embarrass myself further. Oh, Jesus, it says, come on, sorry. Is this a video playing in the back? I'm just going to let it play, that'll be easier.
GFS, okay, so endpoint, I'm assuming that's the account ID, that's the username that I created. Oh, it's an embarrassing password coming from a security person. Great, I wonder what else is missing. Oh, my AWS, oh, okay, API key was there as well. I think I'm going to rotate that after this as well, but I think at least I know I would. So, okay, so he or she had both my username password for Terraform security user and my endpoint, which is my AWS account. Oh, this is embarrassing. They're actually on my account ID. See what the person is going to do now. It's in Stockholm region. All right.
So it's worthwhile calling out here. There's usually a conversation in the community about, is your AWS account number sensitive? This is one of those reminders for me personally, that's why it's sensitive, because just by having the information of my Terraform username, they could not have gone much further if they didn't know the account ID. But they did know the account ID, which is why they could go to the console with that IAM user. So as much as people would like to argue and say it's not supposed to be sensitive, I would kind of feel there is a counter argument to it. But yeah, just wanted to call that out. And hopefully this time it just plays from where it left off.
EC2.
Perfect.
Can they change account? All right. Okay. Fair enough. Tried. Obviously, good. I had restricted permission. Oh, smart. So the person is going to look for what permissions do they have at the moment. Okay. So fair enough. Yeah. Thank you for letting me know I don't have MFA on this user. Unused for more than a year. Oh, wow. Okay. So that's where, fair enough. Ooh, then what? I hope we.
As you can tell, as I was going through video, I'm just sinking in my seat. I was just thinking every time what the person moves to a different place, I'm just going, oh, I can't.
Oh, cool. Okay, so I have permission boundary enough that they can't do anything on this. That's good. All right, so they can't do anything on anyone else. What about, that's good. They can't change anything on anyone else. Oh, there is an active key. Oh yeah, because that's what I had used for my actual Terraform cloud. Oh, okay, so read only, read only, read only, read only, SSM read only permission. That sounds about right. So I think I did some good thing. There is access key, and I'm not part of any groups. Yeah, that's the Terraform bootcamp that I'm running on my Cloud Security podcast channel at the moment. And oh, look at that. SSM can't do anything but resources. Okay, fair enough. But it's all read only. So, oh, except for the start permission.
At this point in time, I'm fairly confident because I only have read-only permission. Pretty standard. I think this person would not go too far. Unfortunately, they did.
Okay. Ooh. Oh, I think I know what the person is going to do now. Can they launch? Oh, looks like they can launch. Oh, okay, could be noisy. So smart. So what else are they gonna do? Oh, smart. They're looking for CloudTrail. I think I'm pretty sure I have CloudTrail turned on. I don't have CloudTrail turned on. No, I don't have CloudTrail turned on. Cannot believe it. Yeah, I don't have CloudTrail turned on. Fail to get CloudTrail events. Okay, so definitely this user can't. So, okay. So I don't have CloudTrail turned on. That's bad as well. That's just pretty bad from a, okay. So far, they cannot do anything apart from looking at IAM user. All right. Well, I see. North Virginia. Oh my God, there is a, oh, this could be bad. This could be bad. Oh, okay. Fair enough. Yeah. Okay. That they're going to try and,
For context, for people who don't know what SSM is, you don't need SSH keys to log in into a box if you have SSM turned on your machine. Essentially, that click of a button that you saw, literally, you just click the button and the person logs in. You don't need SSH keys, no username, password. All you need is just access to the AWS console. So, and you get root access, by the way, just conveniently. Just, why not?
oh my God, they have access to this. This is not happening. This is not happening. Wow, okay. So let's see what they do. It's an assumed role called red team steal credential. But oh, this is the instance ID. Okay, that's the SGS credential of that. Okay, so they're going back into the EC2, or they're looking for the role, and they're looking at SSM managed instance score. Wow.
So this is the IAM role you need for SSM, and to be, I guess, for people who are probably not AWS practitioners. Essentially, this is the service that is used to do auto patching. If you want to do an inquiry, instant response, this is the service that was, I mean, at least the intent behind the service when Amazon released it was the fact that you should be able to, if I'm an instant responder, I don't want to log in, but I want to be able to communicate with it without the need to, say, figure out a password. I should have a user to get in, do inventory, do what the patch level is and other things as well. So that's kind of, and this is the role that's required for it.
Oh, that's another SSM. Oh, that's for the SSM. Oh, no. No. This is bad. EC2 and S3. Oh my God, I can already see what they're going to do. Ah, I knew it. They're going to do this. The person is now. What we'll see. Oh, no. Okay, I wonder what else they're going to do. Oh, okay. So that's a good thing I have CloudTrail. So I imagine they're thinking already that there's a lot of CloudTrail activity. Maybe I don't have the permission to look at the CloudTrail. So they might go move on to something else, hopefully. Oh, it says ransomware bucket. I hope this was just a sample and I didn't want to. make my life hard by actually making myself a victim of ransomware. Oh no, this is bad.
So this was an experiment I was running on ransomware because we wanted to show in the class with some actual data. Clearly, this is production, and we had a bucket to demonstrate ransomware, which we didn't clean up after this thing. So, anyways, embarrassing things continue.
This is actually my accounting files. No, please don't do this something stupid. Please don't do something stupid. This is gonna be okay. There is no bucket policy. Oh wow, now this person just showing off. I don't have any bucket policy. Oh, okay, so they're trying to make it public. Haha! So you don't have access to everything. Okay, all right, what are they gonna do then? Oh, okay. Smart, because the person doesn't want to trigger if there are any notification. Okay then. They can just download everything from my bucket onto this S3. Oh, onto this volume that is there. That's at least this is where system is good. That's awesome. Just don't let them do anything. Yes, go for SSL. Oh my God, they can. They can do that. And oh yeah, they can create direct. Who knew that was that simple? I'm assuming now they're gonna actually do the actual run rather than the minus a dry run. Oh, this is permission 9. Okay, so
I know it got cut off, but essentially they were trying to copy across. So because they can't download. They didn't have access through the IAM role, but on the instance profile, which is the identity connected to the EC2 instance, there's an S3 bucket, but it allows them to at least download the file, or at least they thought they could download the file, but as you can see, there was a permission denied for downloading the file, but they figured out the way around it as well. That's the part that was cut off for some reason. But I'll just let it play towards the end.
I think. Okay, I see them coming on to this. Fortunately, there's no public. Okay, there's no public IP. That's good. Only private IP. What are they gonna do? I'll be surprised. So they have this in the volume. So far we know that they have basically copied it to the volume. Okay, so actions, networking. Okay, might be too noisy. You clearly don't want to set up any alarms. So, oh, okay, all right. I see. Okay. The person might do. Oh, no. No, I know where this is going. I know where this is going. No. Not encrypted. Perfect for the person. Oh my God, the volume's there as well. It's public. That means any AWS account can search for this on the internet. Oh my God, this is not happening.
That's the end of my embarrassing part. So I can go back to getting some dignity back in front of you guys. As I said, that was a walkthrough. I wish it was a lot less embarrassing, but at least there's a few more things we had to cut out. But essentially, the idea was we were grateful that the person didn't choose to actually abuse the function, so I'm definitely grateful. And they were comfortable for us to kind of talk about it, and hence the talk here. To share with you what we learned from this and why a CSPM is not enough. For people who don't know what CSPM is, I doubt anyone doesn't know what CSPM is. Oh God, awesome! Oh, yes, one person who's probably in this bit. This was a good reminder for us is that a CSPM or a CNAP is just not enough for you to actually understand your overall posture. Because anyway, I'll talk about it a bit more. But essentially, what it started was with the Terraform state file. As I was saying, when the version that we were working with required Terraform to have an IAM user, which is a local user in AWS for you to even interact and let Terraform have an activity or be able to extend its access to AWS to create resources on it. Now, from a possible risk perspective, it could have gone down the path of reputational risk. We could have been DDoS. Technically, there was a folder, there was a S3 bucket with sensitive information, which they could have just deleted and given us a ransomware thing. But all of these things, if you think about, they would have just been flagged as a low, because the S3 bucket was not public, the actual instance was not public. So none of these would get picked up as, hey, you have something wrong. IAM role would get picked up because you have an S3 star, but by itself, how many of us have read like a wall of red every time you open a CSPM or a CNAB, which is like, oh, it's an excessive permission. yeah, I'll fix it right away. Why not? So I feel like this is one of those categories that we landed on, but if you look back, it definitely was something that could have been avoided if we were just looking at the low medium. The other part was we had to delete the entire GitHub repo because of Git history. For people who have tried recovering Git history, because once the username password is there in GitHub, it's there in GitHub history, even if you remove it. So removing GitHub history is like a monumentous task. It's how I was told about it. So we decided to just basically get rid of the whole repository and recreate it with no password. For any security architects in the room, this is what it looked like. Essentially, the platform engineer who initiated the, I guess, the deployment from their laptop, the way it would work in Terraform is you have to initialize, which is what that Terraform init is. Then you apply that state. Now, Terraform is basically locally installed on your laptop, and that's where the .tf state file, which is a known extension of how you store the state in Terraform for whether it's your, hey, am I going to talk to AWS, Azure, Google Cloud? And hey, these are the credentials that I'm going to use for talking to AWS, Azure, Google Cloud. So that's where that is stored, and it can obviously use that to talk to any of the providers that it can have the conversation with. So this was my story, but I wanted to link it to, well, again, that's the file that is specifically talking about, which had the access keys. But I wanted to link it to the actual 3 public use cases that happened to kind of give some layers to the complexity. Even though now that you've seen the walkthrough for people who are from an AWS background or even not from an AWS background, you'll see it feels fairly straightforward that I feel I did the right thing by making sure my identity didn't have too much access, or well, my IAM role did not have too much access, but my actual resources where my application was hosted, that IAM role was a bit excessive. And I don't know how many, but I feel like it's a common conversation I hear from people where instance roles are, I'm not going to ask you to raise your hands for it, but I can imagine a lot of us have applications that have IAM roles, which gives the server, the non-human user here, permissions to do a lot of things. But there are public use cases of some of these. For example, the first one I'll call out is for people who would have followed the Uber or, well, I know Uber had a few. This specific one was around the Uber and Datadog one where they had access keys that were exposed to the internet through GitHub, which is kind of like, would give you a hint of where the first one came from. So the kill chain for them started in GitHub, and it was basically the access key had excessive permission to an S3 bucket. That's how they got access to the S3 bucket, and it was exposed internet on, totally. I get that it should not have been the case. These days it's a lot more harder to make a resource available on the internet, but you can still have your access keys on GitHub, which is a public repository, if you want to. The other one was with FTX, where I guess FTX is a very popular fintech company. The CEO got jailed. They had the case of lost IAM user credential, where they lost all that money. They didn't have MFA. They had shared passwords. I don't believe they had a full-fledged security team as well for a while. They just had cloud engineers. But essentially, they lost access to AWS accounts, and which also meant they lost access to the crypto wallets that were there in the secret manager as well. The third and final story, which is probably the most popular one, after that, I can probably switch to, I guess, what I've been talking about so far has just been access. Your IAM role on an EC2 instance has been a popular use case in Capital One. For people who followed it, similar situation, IAM role on the EC2 instance had S3 access to, they were at least giving access to a specific bucket. That specific bucket just happened to have sensitive information in there. That probably was the only fault. And they were also using IMGS v1, which is the API CLI commands you use for AWS. So the reason I talk about these 3 breaches is because if you kind of zoom back and if you see what I experienced in my situation, I kind of ticked all 3 of the boxes in each one of those categories. But unfortunately, I guess the tools that I'm using or I was using don't really specifically go for, hey, this is what Uber had, so we should look into your GitHub access key. It's not linked to any of my CSPM. Like my IAM user is picked up on my CSPM as you have IAM users, but how do I know the context between IAM user, GitHub, and EC2 instance all combined together when it's Terraform? So That's where I wanted to kind of take this conversation that we experienced and maybe use this as a platform to share about, like these days, cloud breaches are a lot more complex. I'm probably, cloud breach is a strong word. I would say cloud incidents are a lot more complex. It's not just about your S3 bucket opening the internet. It's a lot more, the kill chain is a lot more longer and a lot more complex. There are IAM roles that are even nested. Like I didn't go into some of the conversations I've had on the podcast. We've spoken about it's not just one IAM role. Because these days, who has one AWS account or one Azure subscription? Everyone's multi-cloud. Everyone has hundreds of accounts. Our scenario, I think I've got a slide for it. We had about 300 AWS accounts. We are multi-cloud, 100K identities, and we have a mix of EKS, ECS, Lambdas. I'm assuming it's a lot more complex out there. This was just my personal situation. In all of that, if we have a 2-people cloud engineering team, it's probably with the CSPM tool, who are just working on fixing the vulnerabilities that are being picked up as high or very high and verifying them. That it itself takes a long time. So, not that I'm defending what we said, what we did, and what we was absolutely could have been. I guess we could have done better. It's just that these days there's a lot more complexity, and there's not just one AWS account. There's just not one subscription. So I wanted to take this conversation to a few possibilities over here. That screenshot is from Attack MITRE, which is a very popular. I think they are a not-for-profit body, but don't quote me on that. But essentially, what they do is they scour the internet for what are some of the common tools, tactics, and procedures or practices that are used by malicious attackers on the internet. They came up with the one for cloud, and they narrowed it down to 3 things, funny enough. And I would say the valid accounts, trusted relationship, and exploit public-facing application. Only 3 things. And each one of them can lead to, and I guess I hit the mark on all of them, with privileged access to S3 bucket could have led to ransomware. For people, probably I want to clarify, ransomware in the cloud context is not the same ransomware you hear on the news where someone lost access to their machine. In this context, more like someone would have access to your resource. For example, S3 bucket, which is the same as a Dropbox or Azure Blob Storage, they would just completely empty your blob storage or S3 bucket and just leave a node with their Bitcoin address. That's what ransomware looks like in today's day and age in the cloud scope. It's not that you're losing access to your compute, you're losing access to your actual files and resources. So that's what has been seen by a lot of people, and I think I just want to clarify that when I say ransomware, I mean ransomware in the sense that you don't no longer have access to your actual files or sensitive information. The denial of service is the next one where, I guess for people who are running applications are compromised, they can completely choose to just DDoS that as well. But all of that, even like we've been talking about cloud for, I want to say 15 years, and even till today, these 3 are the biggest reasons why people get access to a cloud resource. It's not a 0 day, it's definitely exploiting anything which is publicly facing, like if you have a vulnerable application server that is facing the internet. If you have a third party, for people who would have followed the Okta breach that happened, there's a third party that had access to their machine. Because why go after an enterprise with like the massive machinery when you can go for the smaller player who already has an in the environment? Valid accounts is another one, which is I would say the common use case is phishing or the GitHub access key, leaving secrets in the public. This is the full framework. I'll definitely recommend for people who are curious to look at it. It kind of goes into a bit more on once they do get access, how do they execute it? How do they persist? How do they do escalation privilege? But entry point always seems to be those 3. It's either public-facing resources, it's all valid account credentials, and these days, credentials are no longer just in GitHub, it's also in your CI/CD pipeline. There is this whole, I would even say there's a point of conversation where, do I have multiple CI/CD pipelines per environment? Do each of the application team gets their own CI/CD pipeline, or do we have a centralized CI/CD pipeline? There's a lot more complexity, and all of them have credentials to your production as well. Supply chain these days is no longer me talking about open source libraries. It's also about the CI/CD pipeline I use, my third-party supplier who probably is using AI, that's my worry right now, but I'm also worried about the fact that I have third party that have access to my information, which is third parties like your Terraform in this case. You may have Kubernetes that's running in the background as well. So, okay, all that said, I didn't want to focus a lot on like the problem, as I'm guilty of, like, I want to say a lot of us in the community are guilty of walking with the stick rather than the carrot. So my hope is I can at least share some actionable things that you can walk away with from what we learned and what we found as things we are working on to make it better for, I guess, not just for ourselves, but for educating other people as well about this. The first one that I want to talk about, the three things: threat modeling, which I'm sure some people would roll their eyes on this. The second one, and maybe a lot of people may not be aware of the data perimeter, and the last one is instant response readiness. Threat modeling our application. I would say threat modeling is a very known concept. I don't have to explain to people who, all of you experienced what threat modeling is. In the cloud context, the nuance of it is a bit different. You can still use Stride or any other methodology you have for threat modeling, but what we found in the work we did, threat modeling did not just come up from an application team. We had to have the cloud security people in the room as well. Now, I'm sure some of you may be already doing this, but a vast majority, based on the conversations we were having, a lot of the conversations around threat modeling is primarily either has never happened, or if it did, it was run by the AppSec team through a lunch and learn session, because we were trying to educate people on what could be the possibility. So in my previous role as a CISO, where we tried running a DevSecOps program, we tried starting with secret scanning as a way to start talking about DevSecOps because it made more sense. But then soon we realized secret scanning was just not in repositories. Secret scanning was the APIs that we were talking to. There were API gateway we had to interact with. There was GitHub repositories. There was also Secret Scanner, which we saw in the Uber example as well. Secret Manager, Secret Manager. If you have, like, I would say these days secrets are a lot more complex. It's no longer just username, password. And we soon realized when we were doing threat modeling, we sometimes had spent hours just focusing on only on one thing. Like, we were either just focusing on compute or just focusing on secret for hours, because we just had so many kinds with the scale that we were working with. With that said, if you do run a threat model, I would definitely encourage you to have a cloud security person in the room or a cloud architect in the room. But instead of you being that security person, let them be the security person has been a great thing, because they probably know their environment already. And they have a lot more deeper understanding of how they would break the system than we would. I used to think I'm smart, but I met a few people who are way smarter than me. I'm sure a lot of you are smarter than me as well. But I definitely realized, I was definitely humbled by a lot of people who showed there are still things that I would find in security that I do not know of, even though I've been doing it for 15 plus years. But the point being, when you do threat modeling, definitely have a cloud architect or a cloud engineer who's doing the security breaking part rather than you doing the breaking part. That has found to be the best solution in my case. It definitely found it to be the right part. Stride, for people who probably have not used it, if you are thinking about doing a Stride for, say, I guess some of you may be in an enterprise that is still on-premise or has hooks into on-premise as well, you would find, if you were, I'll just quickly go back onto, like, for people who probably have not heard of Stride, it's spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. So from a spoofing perspective, if you are looking at an application that is hosted in public cloud that has a network connectivity into on-premise, you're spoofing. One example of that would be the fact that only, like, make sure you have authentication. Only authenticated users can log in. And this is, I'm not even going into authorization yet, just simply talking about authentication. Whether you have SAML, single sign-on, whatever you choose as the medium, definitely single sign-on is great. From the firewall rule restriction, this is basically tampering. How do you prevent tampering? There are logical firewalls that are available both on your cloud resources. These days, software-defined network. If you have on-premise software-defined network, you can do logical translation there as well. I want to, someone I was talking to earlier, and they said that in security, we've stopped talking about the boring things because boring things actually somehow prevent the bad things from happening. So we stopped talking about the boring things. I feel threat modeling is kind of similar as well. Sometimes when you may go into a conversation, it's important that it's not us who are talking about security, it's the person on the other end, the cloud person, the developer, the cloud architect. They're the ones who, like, you can point the question to them. This is to, if you were to use this slide or watch this video later on, this is to kind of give you some thought, I guess, plant some seeds in your cloud architect or cloud engineer for, hey, this is what I mean by tampering. This is what I mean by repudiation, that, hey, there's an audit log of what has happened so far. Make sure you have CloudTrail turned on. Make sure you have encryption because you want to maintain integrity. So are there places we don't have encryption? Encryption at rest, encryption in transit. These days, if you're in a regulated environment, you have encryption in memory as well. For people who've been in the regulated industry would probably know this. You guys are working on this already. In terms of the deniability, not applicable for internet facing, which is the denial of service. But I would say, in my case, it was the denial of service would have been still applicable, considering there was an EBS snapshot volume that was made available to public. But hey, I'll leave that aside. The last one, which is elevation of privilege. This, I think, is probably where you can probably add a bit more. Just-in-time provisioning is not an easy thing in AWS, and granted, the talk primarily is talking about AWS. Azure has just-in-time provisioning, some of the other ones as well. But the privilege escalation part in this case is more around whether we give users long-time access to high privilege, or do we maintain it at a lower level? That's kind of where the threat modeling is. But I just want to give a few examples, because if you ever come back to this, at least you have a starting point to have a conversation with your cloud engineers or architects for, hey, these are examples I think of. Does this spark another place where we can look into our thing? That was threat modeling. This is probably, I don't know how many people would be aware of a data perimeter context, but for people who are from the on-premise world, you probably would understand this as, we used to have DMZs in our on-premise world where we would divide the entire network into different zones, where there was like, hey, this is DMZ, anything internet facing, like our web servers and our proxies, they kind of lie on the DMZs. Whereas the deeper you go into the network, the higher the protection, the more private things were. It's the same concept with data perimeter, and there was I would say the concept of doing security in cloud initially started with detection first, and I kind of would blame the CSPMs for it, because they kind of came in the worlds of, we should detect everything, basically things are going to fire. We kind of forgot the prevention is better than cure part. We kind of kept focusing on the detection part. And I'm not saying it's they're wrong. I mean, that's what they're supposed to do. CSPMs, that's what they're trying to sell. And they're doing a great job of at least educating us on how we can do detection. Like, I think the company that I was CISO for before this, we were in AWS shop. And after that, we acquired a couple of companies. We started getting Google Cloud, Azure. None of my team members knew about how to do it. A CSPM was a great place for us to start looking at, hey, what can we consider as, I guess, the tactical things we can look at today to start working on in Google Cloud, which I have no idea what it's about. So they're definitely doing a great job in helping us do that kind of detection, but we kind of just, I feel like we double-clicked on it too much. We stopped talking about prevention. And these days, if you talk to any of the regulated industries who have been doing this for a while, you would find that data perimeter as a concept is that same thing we have done in on-premise. We're trying to create a trusted zone in your AWS environment. This concept does exist in Google Cloud as well, but the idea is simple, where if I, as a user, I'm allowed to do AWS action, how do I differentiate between if it's my personal AWS account or a company AWS account? These days, there are things like organization that you can use for it, but the intent, if you kind of, to give you a few more examples, how do I make sure the network conversation for if I do a data transfer between my on-premise and S3 bucket, that's only the source IP of it is my actual corporate source IP, not someone's personal source IP. That's a very regular thing we would have done on-premise, but somehow when we came to cloud, we kind of forgot that we could do this. And I guess I won't blame any CSPs for it, but there's not a lot of conversation about it. I think if you Google data perimeter, there's only 3 blogs that come up on the internet. Well, I mean, you go, okay, clearly should have been spoken about a bit more. I found this screenshot taken from, I think it's like an AWS blog that I found, where they spoke about the 3 parts that you can define this in. And the way I would explain it is that identity, resource, and network is kind of like the three parameters that you can work around when you're trying to build a data perimeter, where the identity piece is that, hey, only authorizing people from a trusted device in my organization. Like, you can trust identities a bit more if you know the device can be trusted, the source IP can be trusted, and that kind of adds that layer of, hey, you can use principal org ID to validate that I'm coming from the right place. You can also go a step further and have MFA as well if you want, as a higher level of trust. The next part is about resource. If you are worried that, hey, I recently heard this and I thought it's a great explanation. I feel on-premise was like a walled garden, or I guess we knew, actually, I'll probably explain it as a castle. On-premise was like a great castle. There was only one bridge to come out of the castle, one bridge to go into the castle. There's no other way to come in unless you're climbing the wall, which is like hard if you were talking primarily about on-premise. Cloud, I would like to describe as an amusement park with multiple entries and multiple exits. And everyone wants a Disney VIP pass as well for every service that's available. So we kind of have in this, now we got CSPM as a video camera, if you were to take it as a way that, hey, who's misbehaving, who's breaking the rules, where is the castle broken? That's our CSPM. Hey, by the way, you have a building with 25 windows, 5 of them are broken. There's no priority, there's no context, but I guess it's broken, so I should look at it. Resources, I feel like, are on that same category for what I had with my public snapshot. Some CSPMs have rules for it, some CSPMs don't, depending on what they consider as a standard set that is given to us by them. So your teams would have to kind of work on, okay, how do I know that the resources, the public resources are a trusted set of resources that I have intentionally made public? I think there was an example that someone shared recently with me, where if you have an incident, and if you know it's an S3 bucket, which is public, is it my bucket? How did I know about it? I mean, I don't know. It could be anyone's bucket on the internet. How do I validate if it's my bucket? This is where the concept of, I think, the data perimeter on the networking part comes from there. You kind of define what my trusted zone is. You define what your source IP is, that only communication from these source IPs. It's almost like you're creating a stadium. You've turned your Disneyland into a stadium where you at least control access to who goes in, who goes out. You can do whatever you want inside your stadium, but the moment you want to step out or you want to bring a bag in, someone is going to inspect the bag that you're trying to bring in. I think that's what we're trying to go towards, and that's what data perimeter helps you do. So you're kind of moving away from, we did build a castle for a while on-premise, then we kind of shifted on to this amusement park model. Now data perimeter is kind of helping us go towards that stadium model for, we are in that category for, okay, now I'm like checking in any bag that's going in. Is it supposed to go in? Does it have anything? Is it a multiple laptops? Like, I'm sure all of our bags are scanned in. It's kind of like the same model when it comes to this, to have a higher level of trust for, if I was to do that exact same thing this time and someone was to try and copy an S3 bucket, can at least trust that that person has either come from my known endpoint, and also the fact that the person has already validated and made MFA or whatever, they have given me a higher level of trust that they can perform this activity. That's where I would definitely encourage, if someone hasn't looked into it, I think it's definitely worthwhile spending some time on it. It is something that can happen at scale as well. The service you're looking for in AWS is called Organization, SCP. I can't remember the name of it, Schedule Control Policy, I think. But yeah, just if you look for Organization SCP, it helps you define data perimeter across your entire organization. Hopefully you don't have the same challenge that I did. We ended up realizing that there were 2 organizations, which made the complexity even way more, which is another talk for another time. Sweet. Okay, that was data perimeter. The last thing I want to talk about is the incident response readiness assessment. The reason I talk about this, like, we've been doing cloud for little over 10, 15 years. A lot of us have been there for longer, since the first service came out. But if you notice, there's not a lot of conversation around incident response in general. We don't talk about, hey, what happens when there's an incident in cloud or in Kubernetes or any of these things. Some of us have been trying to have this conversation, but a lot of us are still on that verge of, hey, let me put the CSPM and try to have the guardrails set. I want to reduce the number of red alerts that I have on my CSPM to be much lower, trying to be more proactive. Hey, is it going to be the vulnerability management team? Is it going to be the SOC team? Who's going to look into the alerts? A lot of the conversations have bogged around that, and rightly so, at scales that we didn't expect. I think a lot of us were still focused on the conversation for one AWS account, one Azure subscription, which now is scaled down to, like, we have had conversations with people who are with thousands of AWS accounts, where your development commits, the number of commits developers are making is in the thousands per week. The number of change that's going on a daily basis in our organizations is just insane level. How do you even, like, I think just simply saying that, hey, it's the same application from on-premise that we moved to cloud, so the same incident response plan would work, I would strongly disagree with that. And I would say you would also, and I don't think it's spoken about yet, but you would definitely find that the movement for a lot of people who are fixing on code to cloud, you would start seeing code to cloud to SOC movement coming in soon. The reason for that is a lot of people are realizing that once you do identify a vulnerability, which sometimes is too late, but if it's not, who is responding to the incident? Do we have a process defined for it? There's a lot of things that are not spoken about. But I would highly encourage, if you feel fairly confident about your incident response plan, I would definitely ask if you have a cloud environment, what was the last incident that was raised and what was the source of that incident? I bet you most of the time it would be someone external, not your tool. That's what we discovered. And like, okay, I clearly have a lot of gaps. So that's why a lot of us have started, at least in the community, have started talking about incident response readiness. An example of this could be the fact that what I didn't have CloudTrail turned on. Now, fortunately, for people who are in the service, at least you have a 90-day window to at least see the logs. But if this was picked up on the 91st day, I would not have anything to work with. A lot of the incident response conversation mostly starts with, hey, do we have logs? Like the who, what, why. I can't answer that question if I don't have logging turned on, but then the next question then becomes, what kind of logging do I even have available? And how far can I go? How quickly can I give access to an incident response person to a cloud environment, which is the cloud account number 399 somehow? I'm like, have you figured that part out? Have you figured out the fact that we've been doing tabletop exercise for a while, and I've been helping a lot of organizations run tabletop exercise in cloud. A lot of the times, even though we've done threat modeling, we understand what the things are, sometimes the right kind of tooling is also not available for us to even access some of those accounts quickly. So this is kind of like a basic test, but you can go a lot more deeper if you like. And with that said, I think I'm on my last couple of slides. What does not work? I think CSPM, I'm gonna put a statement out there, and once it goes on the internet, people will hate me for this. CSPM as it stands today is gonna die, is what I'll say. And I do mean it, because you'll notice we have parts of CSPM which kind of make sense. Oh yeah, I mean S3 bucket open the internet, but I have 25 S3 bucket open the internet. How do I know this is not from the 25 that I have? It can't tell me that. I still have to manage that on my own. I still have to manage the fact that the 26 seems to be not in my org, someone else's org. There's a lot more complexity to cloud these days than what a CSPM offers. So as it stands today, I definitely believe that the CSPM model would die. And this is beyond the software limit. Like some of the softwares have limits for 100K users. They don't go beyond 100K users. A lot of us in large organizations have more than 100K users in our organization to deal with. And this is, by the way, just human users, not even non-human users. I'm not even going into that. Then a lot of vulnerability, I think I'm guilty of this as well as a CISO. When I run pen test, why don't you just focus on these URLs? Don't focus on these ones. Why don't you just, these URLs don't need to go to the cloud. It's all good. Like, don't worry about the cloud, because I have a timeline for 3 weeks or 4 weeks or whatever, and you don't want the pen tester to kind of go down the path of a cloud vulnerability because you believe you had that covered. At least we did. We believed we had it covered. So these days, pen tests are still focusing on application. I would say even that would need to evolve to have cloud in as a pen test as well. Not in the sense that, hey, what can you tell me from a CSPM perspective? It's not just misconfiguration. Things like this, which are obvious, someone has to actually sit there and go through the path. How far can I go through this trajectory and actually validate the attack path instead of just making up one saying, hey, there are 3 hops here. You should be able to do this. All right. My hope is the first step is always the hardest, as a lot of people would know this. I wanted to give you something what you can do today. Anything that you take away from this talk, I would definitely encourage you to look into the SCP or data perimeter. It is not spoken about enough. We are able to do prevention and not detection. We don't have to be ambulance chasers if we don't want to. Totally fine if you enjoy that, but if you don't, I would highly encourage you to do data perimeter. Use Amazon SCP for it. As I said, there's 3 blogs on the internet, but if you want more information, happy to connect with you guys later. And I would also encourage you to do user access management onto the cloud environments. These days, you can do that automatically through using API, but definitely doing it at scale is harder. But I'll definitely encourage you to see if you have a defined process for what user access management looks like in cloud at the scale that you have in your organization. And last but not least, when was the last incident raised in your cloud environment, and what was the source? Just a curious food for thought for people. That said, thank you for your time. I'll have to take questions as well. I think we have a few minutes for questions, so 3 minutes for questions. Awesome. Any questions? Now that I've embarrassed myself enough. You don't have to walk to the mic. Cool. Everyone understood everything. Awesome. Oh, there's a question. Awesome. Thank you.
Not really a question, but a tip for everybody. This morning there was a presentation from 2 AWS engineers on data perimeters.
Oh, perfect.
And
there
it
you
was
go.
excellent talk. So
Perfect. Highly recommend that talk.
favorite in your schedule, download and look at it. It was
I will look it up as well. Thank
excellent background on what data perimeters are, how to implement.
Oh, perfect.
Just download the code from them and start going.
I will do that. Thank you so much. Thank you for your time, everyone. Thanks so much.